Hey Math 1B, got a new video for you. It's a new chapter, very, very, very different from the one previous to it. 3.1, we're going to talk about exponent properties today. Pretty much just two main things. What do you do when you multiply two powers that have the same base? X's are the base. And what happens when you take a power to a power? That's on sort of the next page of this and possibly on the next video. So, let's jump into it. So think about x to the 6th power times x to the 4th power, which could also be rewritten with parentheses. These two basically mean the same thing. Well, I guess we need to understand what these little numbers mean. The little numbers are called exponents. The exponents tell you how many times you take the base times itself. So, this is x times itself 6 times. 1, 2, 3, 4, 5, 6. This is x times itself 4 times. And you're multiplying these two together. What's the answer? X to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is x to the 10th power. So, when you multiply two powers together like this, the shortcut is, if they've got the same base, all I got to do is add the exponents together. 6 plus 4, 10. So, sometimes in textbooks you'll see it written as x to the, a power plus times x to the b power, and they'll just say that, hey, it's now 1x base, and then you add them together. So there's our first rule. So what do you do when you start getting coefficients in front? So you got 8x to the 6th power times 7x to the 5th power times 4x to the 3rd power. Well, technically 8x to the 6 is 8 times x to the 6 times 7 times x to the 5th times 4 times x cubed. Just wanted to establish that there. And there's this property. It's called the commutative property. Which allows us to rearrange the terms to get the like terms side by side. So what I mean by that is, I'm going to rearrange it so that the 7 is right by the 8, and then the 4 is going to be right by the 7 and the 8. So you're going to say, let's do 8 times 7 times 4 using the commutative property, and then we will group the x to the 6, x to the 5, and x to the 3 together. So right here is that step. So at this point, you guys got calculators. You can do 8 times 7 times 4. 224. And then for these, I think we established that the pattern is, if they've got the same base, they're all x's, then you can just add 6 plus 5 plus 3. Six plus 5, what am I using a calculator for? It's 14. Okay, so what does it look like when we've got not just x's, but maybe some other variables involved? So this is all multiplication. I'm going to try to get the 2 with the 4. And I can do that because of the commutative property. I'm going to get this a term with this a cubed term. again, commutative property, I'm going to get b squared with b squared, and then f to the 2 times f to the 2. Eight. This is 8 of the 1 times 8 of the 3, so that's going to be 8 of the 4 power. B squared times b squared is b to the 2 plus 2. And f squared times f squared is f to the 2 plus 2. All right. Hopefully you guys are starting to get the hang of it. Pause the video and try 2 on your own. All right, let's see what you got. You should be grouping 8 and 4 together. Let's see, I'm going to keep it in alphabetical order. So I'm going to do x cubed times x to the 7. Then I'm going to do y to the 7, y to the 6. And then z to the 6 times z to the 5. X to the 10, y to the 13, and z to the 11. A lot quicker than substitution method, no? All right, the last one of its kind looks like number 3. Again, I would encourage you guys to hit pause and try this on your own. All right, let's see if you're correct. Should be negative 4 times 6. A cubed times a to the 6. B to the 4 times b. C to the 2 times c to the 10. And that's it. Negative 24. A to the 9. B to the 5. And then c to the 12. All right, I'm going to keep this video rolling. If you got through 1 through 3, then you understand half the concepts for this section. Here's the other half. So instead of x to the 6 times x to the 3, which equals x to the 9, what is x to the 6th power to the 3rd power? Well, we can clear this up pretty quick. Try this. This 3 means take x to the 6 times itself 3 times. So you can rewrite it if you want to. This is going to be x to the 6 times x to the 6 times x to the 6. And you know the rule that if you're multiplying powers that have the same base, all you do is add them. 6 plus 3 was 9. So you're just doing 6 plus 6 plus 6, which is 18. So that's the answer. X to the 6th power to the 3rd power is x to the 18. So what's the new rule? I'm sorry, you guys couldn't see that very well. We would multiply when it's a power to a power. When it's a power to a power, you multiply. Kind of like if you see parentheses there and you're taking to another exponent, you're definitely going to multiply first. If it's just these two multiplied power times a power, not power to a power times a power, you add them. So let's see what this looks like in action. So if you had negative 3ab to the 4 to the third power, again, I could rewrite it 3 times. I could rewrite this 3 times, or I could just say I'm multiplying the 3 times every exponent inside the parentheses. So b is just going to be b to the 4 times 3, b to the 12. A is going to be a to the 1 power times 3. That'd be a to the third power. Now here's the tricky part. Negative 3 is negative 3 to the 1 power times 3. So it's negative 3 times negative 3 times negative 3. It's negative 3 to the third power. So you actually have to multiply that out. You're not going to take negative 3 times 3. You're going to take negative 3 times negative 3, which is positive 9. And then you're going to take that times negative 3 again. It's negative 27. So if that's still a little confusing, let's check out number 5. Before I try to get constants with constants, j's with j's, and k's with k's, I need to make sure that I distribute this 2 to everybody. And this 3 gets distributed to all parts in its parentheses. So 2 times 3 is k to the 6. 2 times 2 is j to the 4. Negative 3 squared is going to be negative 3 times negative 3. That's going to be 9. All right, move on to the next part. The 3 goes to the k. That gives me k to the third power. The 3 goes into the 2 for j. That's j to the 6th power. The 3 goes to the 2 as well. That's going to be 2 to the third power. So that's 2 times 2 times 2. 4 times 2, 8. And since there were parentheses separating them, it's multiplication. At this point, it turns into a problem that looks a heck of a lot like number 2 or number 3. Where all you guys got to do now is rearrange things. I want the 9 and the 8 side by side. Flip them around. I need the j's side by side. And then I need the k's side by side. So then you get 72. J to the 10 power. Remember, you add the exponents when you multiply powers of the same base. And then it's going to be k to the 9. Hit pause and try 6 on your own. All right, let's see if you got this. 3 goes to everybody inside here, so it's going to be y to the 5 times 3, n to the 6 times 3, and then negative 2 to the 3 power. Negative 2 to the 3 power is going to be negative 2 times negative 2, which is 4, times negative 2, 1, 2, 3, negative 8. This next one would be y to the 3 times 3, y to the 9, n to the 3 times 3, n to the 9. Negative 6 to the 3 power. You know, and this might be a good time to bust out the calculator, where you do negative 6 and then hit the caret button. Make sure this is in parentheses, by the way. Put a 3 down. It should give you negative 216. First group, second group, third group is going to be y to the 6, n to the 6, and negative 1 to the 6. Negative 1 to the 6th power is not negative 6. It's negative 1 times negative 1, which is 1, times negative 1, which is negative 1, times negative 1, which is 1, times negative 1, which is negative 1, times negative 1, which is positive 1. You take 1 to any power, and it's going to either be 1 or negative 1. This one ends up being positive 1. Again, this calculator should confirm it by taking parentheses, negative 1, caret to the 6th power. All right, regroup them. Negative 8, negative 216, and 1 come together. The n's come together. N to the 18, n to the 9, n to the 6. The y's come together. Y to the 15, y to the 9, y to the 6. Sometimes grouping them like this is helpful. And then you take 8 times 216. I think I know what that is, but let's check it on the calculator. Yeah. 1,728. That's not what I thought it was. And 18 plus 9 is 27, plus 6 is 33. 15 plus 15 is 30. There we go. All right, I know this video's past 17 minutes already, but I figured that you guys might want to see at least one example where you see brackets, because I think it shows up in at least 3 homework problems. It's a quick fix. The brackets are just another set of parentheses. Brackets are, can you guys see all that? Another set of parentheses. So if we just think of these as more parentheses, you are just multiplying the outermost n. So this is the same as 3 times 5. It's going to be negative 3a, b to the 4th to the 15th power. Then you multiply 15 through just like you did before. So it's going to be b to the 60 power, a to the 15, and then negative 3 to the 15th power. That's going to be an extremely large number. It's not negative 45. It's this number. All right. Hey guys, that's all I got. Thanks for sticking around, and I appreciate you watching these videos. Hopefully it was helpful.